All right, happy Tuesday, everybody at home. We're going to sit here. We're going to do the first four together. So let's get started. So we don't waste any time. This is what we've been doing, or what we did yesterday. This is combined like terms. We've done this before. First thing we want to do is look at all of our steps. And remember, all the steps are, and you have this reference sheet. It's listed under materials in your Google Classroom. So anybody wants this. It's distribute, where we have the parentheses. Combine like terms. We're going to make boxes and circles. Remove the extra lowest variable. I prefer the lowest, but any variable will work. And then we're going to remove what's added or subtracted to the variable and remove what's multiplied or divided to the variable. And we'll get to that today. So first, we're talking about, can we distribute? No, there's no distribute. Can we combine like terms? Yes, no. So we're going to go over here and we're going to combine. And Christopher, please tell me, which numbers can we combine? Or terms? The 7, and we combine the 7 with just the -6, right? Not the k. Because these do not have a variable, this has a variable. So just these two, -6 is going to be done on by itself or with another k, but there is no other k. Remember, it's only this side. We don't jump over and add the 13. Because the 13 is just on its own. That simplification is per side. So 7 minus 6 is 1. Bring down that -6k. Now we do the last two steps, and this should be simple. You're going to get rid of its add or subtract to the variable. Well, if I start covering up numbers, that's -6 times k. And if I cover up the 6 here, that's -1 minus k. Well, we're going to look in the front of that 1. It's a plus. That negative goes with that 6. So we are going to, since plus 1, we're going to subtract 1 from both sides of the equation. With our opposite operations, our plus and minus go away. We have -6k equals, and then 13 minus 1 is 12. And our last part is what, Chris? What are we going to do with the -6? What is always the last step that we always do every single time? Divide. Yep, because we're going to get rid of fractions before we get there. And if we do have a fraction when we get there, we're going to multiply by its reciprocal. All right, so our opposite operations, they're gone. We're left with k equals, and 12 divided by -6 is -2. Rome, did you get that already?
Yeah.
All right. You know the process. Walk me through it, Chris. So, can I distribute?
No.
Can I combine like terms?
Yes.
Yes. This side?
No.
This side?
Yes.
Which ones can I combine?
7.
And the +7. Very good, because they do not have a variable. This one has a variable. So, -7 plus 7, guys, believe it or not, they're opposite operations. They're gone. All I'm left with is -2a equals 6. All right. This is going to happen on yours. Is there an extra variable? Is there an extra variable over here? No, there's no variable, just one. So is there anything added or subtracted to the a, Chris? No. So we skip it. We go to number 5, and that is remove what is multiplied or divided. So what are we going to do to get rid of this -2? What? What? There's nothing added or subtracted to it. You just said that. So what's the last step? This is -2 what, a? -2 plus a, -2 minus a, -2 times a, or -2 divided by a? Where do you see a division line? It's times. What's the opposite of times? Divide. That's it. Process. Has nothing to do with the numbers. Our 2's are gone because there's opposite operations. That's multiplied by a -2 and divided by -2. They're opposite operations. They become 1. 1 times a is simply a. Looks like a 9. It's a. 6 divided by -2 is -3. That's it. We skipped the add and subtract part of it because it wasn't there. You can skip steps. Next one. This one, guess what? We can skip a step here too if we want to. Chris, what are my like terms?
Eight
8x
x and the -7.
and the -7x. Excellent. Well done. So 8 minus 7 is 1x, or I could just leave it as x, and I'll tell you why in a second. Bring down the 2, the equals, and the 8. And here's why I'm just going to leave it an x. You can put a 1 there, and later on you can divide by 1. I don't care. But if I do it this way, is there an extra variable? No. Is there anything added or subtracted to the x? Plus 2. That is plus 2. That 2 is not attached to the x. It would have to look like this. So yes, it is added to it. Do you see the plus? Do you see no plus? These two are multiply and divide. This is added or subtracted. Do you see the difference between those? You have to be able to recognize that. Otherwise, you're never going to do this. We need to subtract 2 from both sides of the equation because it's plus 2. And it's not attached to the x. Our opposite operations are gone. We're left with x. And by the way, 8 minus 2 is 6. And it's done. Now, if you had chosen to put the 1 in front and you wanted to continue to have the 1 and you wanted to divide by 1, you are still going to get the same answer because 6 divided by 1 is 6. The 1s are opposite operations. It's x. However you chose to go about that. Some people feel more comfortable leaving the 1 in front because sometimes they need to use it. All right, here's the next one. Rome, you want to give me my like? There's no distribute, right? So we're gonna go like terms. What are my like terms? Yeah, now that's pretty good. You can put the 1x here because I actually need to use it. 1 minus 6 is negative 5x. I bring down the minus 7, the equals, and the negative 7 there. Yeah, it's the 7. Do you see that, Chris? Look, if I cover up my number, what does it say? Minus 7. Minus. X minus 7. If I cover up that minus 7, what is that? No. What's the operation between the 5 and the x? The negative 5 and the x. Do you see a subtraction between those two? Subtraction would look like this. What is always when it's attached to the x? What is it always? This is negative 5 times x. Every single time that it is attached to it is division. 3 times x, 4 times x, 10 times x, 15 times x. 3 times p, 4 times p, 10 times p, 15 times p. X divided by 5, x divided by 10, p divided by 10, p divided by 100. It doesn't matter. Those are what we look. These are multiplication. So we're looking for what's added or subtracted to the variable. If I cover that up, that's x minus 7. That's what I'm looking for. If I cover up the minus 7, I'm looking at negative 5 times x. Well, times is the very last thing that we do. So we are going to add 7 to both sides. Now, here's a big problem that we have. These opposite operations on this side are going to disappear. They actually become 0, and negative 5 times x plus 0 is negative 5 times x. That's why we say they disappear. But they don't over here. Guys, this is negative 7 plus 7 is what? No, negative 7 plus 7, 0. Now, most of you just said the answer is negative 5x. That is not true. You still need to get rid of the negative 5, so you need to divide by negative 5, our last step. These two are gone. You can put in your calculator 0 divided by negative 5, and your answer is going to be 0. The answer is 0, not negative 5x, okay? So make sure you do that. Make sure you understand where you're going, because these get heavy. And you should have these 2 steps down. This we've done more than anything else. That add, subtract, multiply, divide. It's the same thing. You just got to ignore all this stuff at the top. You have to ignore this when you get to it. You just have to understand, where am I at? What am I doing on that particular step? It has nothing to do with the numbers. It has to do with the process. Where is the process? That x minus 5 or that negative 5 times x. You have to understand what you're looking at. This could be blah times x. This could be minus blah. It makes no difference. Chris, you understand that? It's whatever is being multiplied, whether it's 10 or 15 or 50,000 or 550 billion times x. It's what's being multiplied is what we're going to divide by. What's being added or subtracted is going to be whatever it is. Minus 50, minus 1,000, minus 10,000. It doesn't matter. If it's minus, we're going to add. If it's being added, we're going to subtract. It's all about opposite operations. It's all operations. It has nothing to do with the numbers. Okay? So we have to get to understand that. If we don't understand that, you're not going to do well in algebra. It's just plain and simple. These 5 steps, these major 5 steps that we are doing are more important than anything you do in algebra, because these will lead to 90% of everything that we do from here on out. So you got to understand this. You have to understand this. If you don't, you're going to have trouble for the remainder of the year. All right. Do your work. See you guys later.